Welcome to this CBSE and NIOS level guide to bond parameters. We will build intuition for bond length, bond angle, bond energy, bond order, and bond polarity. We will also compare typical values that you can use for quick estimates and problem solving. Here is a handy reference table of typical covalent bond lengths in picometers and bond energies in kilojoules per mole. These are average values that may vary slightly with molecular environment, but they are excellent for quick comparisons and Hess's law estimates. First, bond length. This is the distance between the nuclei of the two bonded atoms. It is often measured in picometers, where 1 angstrom equals 100 picometers. For example, the hydrogen-hydrogen bond length is about 74 picometers. Shorter arrows mean shorter bonds. Next, bond angle. This is the angle formed at the central atom by lines joining it to two bonded atoms. We will use water as the example. Water has a bond angle of about 104.5 degrees. The central oxygen sits here, and two hydrogens are attached at an angle. We can draw the angle arc and label it 104.5 degrees. Now, bond energy, also called bond dissociation energy, is the energy required to break a bond in the gas phase. Higher bond order usually means a stronger, higher energy bond. Here is a quick comparison of 5 common bonds. Let us connect bond order, bond length, and bond energy for carbon-carbon bonds. As bond order increases from single to double to triple, bond length decreases and bond energy increases. We will place the 3 bonds side by side, label their typical lengths and the typical energies. Finally, bond polarity. If two atoms have different electronegativities, they pull electrons unequally. The oxygen-hydrogen bond is polar, with oxygen partially negative and hydrogen partially positive. We draw a dipole arrow pointing toward oxygen, indicating electron density pulled toward oxygen. Here is how you can use these parameters in exams. 1. Compare bond strengths and lengths using bond order. 2. Predict shapes using bond angles with VSEP are ideas like linear, trigonal planar, and tetrahedral. 3. Estimate reaction enthalpies with average bond energies using a simple rule. Delta H approximately equals bonds broken minus bonds formed. Remember that the numbers in the table are averages, so your estimated delta H is an approximation. Summary. Bond length is the nucleus to nucleus distance. Bond angle is the angle at the central atom. Bond energy is the energy needed to break a bond. Bond order connects length and strength. Bond polarity depends on electronegativity difference. Use the table to compare bonds and estimate heats of reaction. Keep this reference handy for CBSE and NIOS problems. Practice by comparing bonds in different molecules and estimating reaction enthalpies.